students, welcome to Easy BTech channel, and today my topic is some related problems about PDE. So before doing the problems, please like, share, subscribe our Easy BTech channel. So the question is like this: if r square is equal to x square plus y square plus z square and u is equal to r power m, then prove that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equal to m into m plus 1 into r power m minus 2. Okay, so two functions was given in the question. So at first I am choosing the first function, that is r square. Then r square value is x square plus y square plus z square. So make it as it is equation 1. Then doing partial differentiating of equation 1 with respect to x. Okay, the first doing partial differentiating with respect to x. Dou by dou x of r square is equal to dou by dou x of the RHS term x square plus y square plus z square. So at first explanation about the RHS term. So what is the RHS term here? Dou by dou x of x square plus y square plus z square. Do the multiplication with dou by dou x to the individual terms like this: dou by dou x of x square, dou by dou x of y square, dou by dou x of z square. So the differentiation will be like this, students. So we are doing partial differentiating with respect to x to the function x square. Okay, so with respect to x we are doing, x function is there, then the differentiation answer, x square differentiation answer is 2x. Similarly here with respect to x is there and the function is y square, that means there is no x, then differentiation does not exist. Okay, and coming to the last term, with respect to x here we are doing and z square is there, there is no x, then differentiating answer does not exist. And coming to the LHS part, and LHS is nothing but r square here. According to the same logic thing, if you are applying here we are doing partial differentiating with respect to x to the function. Of course there is no x, then you are assuming that total this partial differentiating value is 0. You are thinking like that, but no, students, this partial differentiating value does not equal to 0. Why? Because it was given that in this question r square is equal to x square plus y square plus z square. What is the meaning of this one here? R consisting of x variable, y variable, z variable. So that means here when we are doing partial differentiating with respect to x, ry, rz to the function, the differentiation answer will be exist for the function r square. Why? Because r consisting 3 variables. What are the 3 variables? X variable, y variable, z variable. So when we are doing partial differentiating with respect to x, r with respect to y, r with respect to z to the function r square, differentiation will be exceeds. The differentiation need not be equal to 0. That means r square differentiation is 2r. And again doing partial differentiating with respect to x to the function r. So again why here we are doing differentiating with respect to x mean, at first we are applying differentiation formulas for power values. That means r power square. For square we applied the formula. So what is that formula? So partial differentiating of x power n is n into x power n minus 1. So first we did the differentiation partially for the power and then doing the differentiation for the function. So now I am writing the corresponding answers here. R square differentiation is 2r dou r by dou x, and RHS answer is nothing but 2x. Then this 2 and this 2 will be cancelled. Finally, the value of dou r by dou x is equal to x by r. Keep in your mind this answer. What is this answer? dou r by dou x is equal to x by r. Okay, so now again doing partial differentiating with respect to y to the same function. So partial differentiation of equation 1 with respect to y. Now I am writing that thing. Dou by dou y of r square is equal to dou by dou y of x square plus y square plus z square. Okay, and again the LHS part, here also the LHS part is partial differentiating with respect to y to the r function, it means r square function. So now I am doing the differentiations here. Then dou by dou y of x square plus y square plus z square. So individual multiplication, dou by dou y of x square, dou by dou y of y square, dou by dou z of z square. Okay students, so here listen carefully. With respect to y, here we are doing, there is no y here, then partial differentiating answer is 0. Okay, and y here we are doing with respect to, and y square, y is their function, differentiation exists. And with respect to z here we are doing, sorry, with respect to y here also, not z, with respect to y here we are doing, and there is no y here, then answer is 0. Okay, so the coming to the LHS part, dou by dou y of r square. Now only I told to you students, r always consists 3 variables, x variable, y variable and z variable. Then differentiating is 2r for the power, and for the function dou r by dou y. So now doing the substitutions, differentiation substitutions, 2r dou r by dou y and is equal to 2y, and these 2 will be cancelled, and finally the value of dou r by dou y is equal to y by r. So keep it in this answer also in your mind. So what is the dou r by dou y value students? Dou r by dou y is y by r only. So now again doing with respect to z, the same procedure we are following here. That procedure is partial differentiating equation 1 with respect to z. Okay, then dou by dou z of r square is equal to dou by dou z of x square plus y square plus z square. Yeah, let me explain about all these two partial differentiating. Dou by dou z of x square plus y square plus z square. So dou by dou z of x square and dou by dou z of y square, dou by dou z of z square. Yeah, coming to the answer. Listen carefully students. We are doing with respect to z, and there is no z here, answer is 0. Doing with respect to z, there is no z here, answer is 0. With respect to z here doing, z is there, answer will be exist, that is 2z. And LHS part, dou by dou z r square, first applying formula for the powers, that means 2r, and again applying partial differentiating to the function, that is dou r by dou z. So now the substitutions, all values. Okay, yeah, the substitutions. Yeah, what is the value of dou by dou z of r square? The value is 2r dou r by dou z, and here the RHS part is 2z. 2 will be cancelled, and the value of dou r by dou z is equal to z by r. Please keep in mind this answer also, partial differentiating with respect to z answer also. What is that answer? Z by r. Z by r students. Okay, so what is the value of dou r by dou x? X by r. What is the value of dou r by dou y? Y by r. And what is the value of dou r by dou z? Answer is z by r. Okay. So one more function was given in this question. That function is u is equal to r power m. Now I am writing that function. So given, okay, given u is equal to r power m. So by using this function only we have to prove that question. So now I am doing the partial differentiating equation 2 with respect to x. Yeah, I am doing dou u by dou x is equal to dou by dou x of r power m. Okay students, so the LHS part as it is I am writing dou u by dou x. So now only I told to you r always consists of 3 variables. So with respect to x here we are doing, so r consists of x value, that's why the partial differentiation will be exists here. Then that means m into r m minus 1. What is this formula here? So here dou by dou x of x power n, differentiation formula, n into x power n minus 1. I am applying this formula here. So n into x power n minus 1 and again applying the differentiation partially to the function. At first applying powers and then applying function. Okay. M into r power m minus 1 dou r by dou x. So what is the value of dou r by dou x? Yeah, very good. That value is x by r only. So what is the value of dou r by dou y? Value is y by r. What is the value of dou r by dou z? Yeah, of course it is z by r only. Yeah, now I am writing this answer, m into x into r power m minus 2. So how you will get r power m minus 2 suddenly? So let me give the explanation about this value. See, what is this value students? M into r power m minus 1 into x. Okay, x by r. Okay, so m into x power x into r power m minus 1. Denominator value is r and r power is 1 only. So if r comes to the numerator, the power value becomes as a negative. Okay, I am writing this thing here, r power minus 1. Yeah, m x r power m minus 2. So that value only I wrote here. So what is that value students? M x r power m minus 2. So now which value this one? Dou u by dou x. But our question consists dou square u by dou x square. That means again you have to do the differentiation of dou u by dou x. So again doing partial differentiating with respect to x. Okay, for this term. For this equation we are doing second time differentiation. See, I am writing here dou by dou x of dou u by dou x is equal to dou by dou x of m x r power m minus 2. Observe the RHS term students. So what is the RHS term here? So m x r power m minus 2. Okay, so what is the value of RHS? M x r power m minus 2. So if you want to do the differentiation RHS term, of course the LHS term is dou square u by dou x square. So please make it as a m common here, then the remaining terms here x into r power m minus 2. So why here we did m as a common? Why? Because we are doing partial differentiating with respect to x students. X is there and r power m minus 2 is there. We know that r consisting 3 variables. That means x is also there in r and x is there. Treating m as a constant. That's why make m as a common here. So now applying u into v procedure. So x into u into v dash, that means doing the differentiation of r power m minus 2, then m minus 2 into r power m minus 3 and again writing dou r by dou x. Again why here we are writing dou r by dou x students? At first we are applying formula for power. For m minus 2 we applied there and then applying partial differentiating for the function. What is the function here? Function is r only. Okay. and plus r power m minus 2 and u dash value is 1. So u dash means here u is equal to x, then u dash means differentiation becomes as a 1 here. Then m into x into m minus 2 r power m minus 2. So what is the value of dou r by dou x, students? Yes, correct. That answer is x by r only. So very nice, students. R power m minus 2. Okay. And m into, here one x is there and one more x is there here. That means x square and m minus 2. Okay. And r power m minus 4 plus r power m minus 2. So how we will get r power m minus 4? Here r power 1 is there and it comes to the numerator, becomes as r power minus 1. Then r power m minus 3 minus 1 becomes as r power m minus 2. So now making r power m minus 2 as a common. Okay. R power m minus 2 as a common here. In the first term, if you are making r power m minus 2 as a common, and then x square into m minus 2, and again r power m minus 2 common, then again the remaining answer is r power minus 2 plus 1. So how you will get r power minus 2 here? See here, students. R power m minus 4 is there. I am writing r power m minus 4 as r power m minus 2 into r power minus 2. Because bases equal, you can add the exponents terms. So which one we make a common here? This term. R power m minus 2 we make a common. Then what is the remaining term? R power minus 2. That term only I wrote here. R power m minus 2. Okay, students, I think you understood this step. Yeah, coming to the simplification. And m r power m minus 2 and m minus 2 into x square by r square plus 1. Okay, students, simply I wrote r power minus 2 as a r square here and again plus 1 here. So which value, students, this one? Dou square u by dou x square. So actually the question consisting as dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square. But only we did only differentiating two times differentiating with respect to x. Then to add these three terms, again you had to do with respect to y 2 times and with respect to z 2 times. But without doing the two times differentiation, using dou square u by dou x square value, using this value only, we are writing next terms here. That means how it is possible to write. Then similarly dou square u by dou y square. So see here, students, in dou square u by dou x square, first two terms are m into r power m minus 2 as it is terms. When we are doing with respect to y, the same values will be comes here. And the next one, m minus 2 as it is, only this term will be changes. If you are doing with respect to x, then you will get x square by r square. Then if you are doing with respect to y, then you will get the answer as y square by r square plus 1. So here multiplication and here not addition, here multiplication only. Okay. M minus 2 into y square by r square plus 1. So similarly, if you are writing with respect to z, dou square u by dou z square. So what will be the value? M into r power m minus 2 and m minus 2 into, so instead of y square, writing z square by r square plus 1. Okay, have you understood, students, how I am writing the dou square u by dou y square and dou square u by dou z square values here? Okay, so now these three values, adding these three values, dou square u by dou x square, dou square u by dou y square, and dou square u by dou z square, because that one is the LHS part of our question. So now I am adding all these three. Okay, adding. See how I am adding here. The first thing, dou square u by dou x square, and dou square u by dou y square, dou square u by dou z square. So I am adding these three terms, students, these three. So when you are adding these three terms, this first term, m into r power m minus 2, m into r power m minus 2, m into r power m minus 2 is the common for three terms. That's why I am making total common term, that m into r power m minus 2. Remaining terms, m minus 2, okay, x square by r square plus 1, first term. Okay, students. And next, m minus 2, y square by r square plus 1. Okay, students. And next one, m minus 2, z square by r square plus 1. So simply m into r power m minus 2 common, adding remaining all terms. Okay, so m into r power m minus 2, and these bracket terms, observe m minus 2 is a common, m minus 2, and making m minus 2 common. So what are the remaining terms? X square by r square plus 1, and plus y square by r square plus 1, and plus z square by r square plus 1. Okay, students. Yeah, now observe this term, x square by r square, and y square by r square, and z square by r square. So m into r power m minus 2 and m minus 2, these three terms, and this one, and again this one, x square by r square, y square by r square, z square by r square, and plus 1 plus 1 plus 1 is 3. Okay, adding the 1 3 times is there, then adding 1 plus 1 plus 1 is 3 here. Yeah, and here in RHS, x square by r square, m into r power m minus 2, and m minus 2 into, so denominators are same here, then x square plus y square and plus z square by r square plus 3. Okay, and the next thing here, m into r power m minus 2 and m minus 2. So x square plus y square plus z square is r square. So how we'll get r square? Because it was given in the question, that is r square is equal to x square plus y square plus z square. So I substitute that value, r square value, in the place of x square plus y square plus z square. So that finally m into r power m minus 2 and m minus 2, and this value will be cancelled, and plus 3. Okay, so what is the final answer? M into r power m minus 2 into m plus 1 implies m into m plus 1 into r power m minus 2. Yes, that's the proof. Thank you for watching, students. Please like, share, subscribe our Easy BTech channel.